So just like you might actually either enjoy this or you'll really hate it, but this is the difference between. So this is I'm just going to call this like integration techniques and non elementary integrals. All right. So hopefully you remember that term, non-elementary integrals. But there were three different integrals that I know that I I gave you, and one of them was x e to the x squared dx, and one of them is x cubed e to the x squared dx, and then one of them was e to the x squared dx. All right, so hopefully you remember seeing those three, and then the real issue was somebody asked me about using integration by parts on these because, or what the first step would be for all of these. So yeah, of course, this one, the the easiest way is a U substitution. So if I used a U substitution here, I have U is equal to x squared, du will be 2x dx. So then I could rewrite this as 1/2 integral of e to u du, and so that would be 1/2 e to u plus c, or 1/2 e to the x squared plus c. That one is easy. All right, but even the next one isn't necessarily easy, um, but what you actually could do though is you could use a u substitution. All right, so let's use a U substitution, but the U substitution will be a little bit different here because your U would be x to the third. So then du will be 3x squared. Yeah, dx. All right. So then if I look at what's going on here, then I I can rewrite this integral as, all right, u, oh boy, here, let me have a seat here. Oh, okay. So u, and then uh, do you see what is going on here? That you have e to the x squared, right? But if u is x to the third, then that means that the cube root of u is equal to x. So this is e to the power of uh-oh. Yeah. Okay. So cube root of u to the second power, and then we need dx. But this is a bit of a problem because I have the 3x squared dx here. So I might actually want to think to myself that I have to rewrite this as x times x squared dx, so that 1/3 du will be x squared dx. So this u actually here should be just this x here, which means that it's actually to the cube root. All right, so cube root of u, and then we have 1/3 du. So hopefully this makes sense that this is not the most obvious problem here. So now what I'm actually going to do is I'm going to apply a V substitution. just so I don't use u again, all right? So if I apply a v substitution, then I'll let v be, let's just let it be the exponent here. So the cube root of u squared, or u to the 2/3 power. So then that would be, all right, so dv is 2/3 u to the, oh, 2/3 u to the negative a third power du. All right. So now if I go ahead and I convert this integral to v's now, I'm going to bring out the third, this third, so I don't forget about it. Then I have integral of, now remember this is a 2/3, and I have u to the negative 1/3, so it's 1 over cube root of u du. But this actually was cube root of u du. So what do I need to do to make it so that this is actually uh, exactly what I wanted it to be? Well, this actually ends up just being, well, um, where is it at? The 2/3. So yeah, so I have to multiply by the 3/2, right? So 3/2. Then we have e to the v power, because that was the exponent here, and this ends up being v dv. So why is this a v here? Well, think about exactly what happened here. All right, so this was the, where was it? I lost I lost where it was. All right, so it was the cube root of u du, and I want to convert that so that it's the 3/2 v dv. All right, so just remember exactly what happened here, right? So v was u to the 2/3. So then I take this to the 3/2 power to solve it for u, or in other words, I could cube each side and I get v cubed is u squared. All right, so just remember that also. All right, v cubed is u squared, and so this is actually, if I want u to the 1/3 power, all right, what I would do actually is I would take this to the 1/2 power, so v to the 3/2 is u, then u to the 1/3 would actually be v to the 1/2 power. All right, so then the this is why I said that it's going to get very wild for you here, because I just said that this is actually 2 over 3 v to the 1/2, and then you had the du, so that was equal to dv. So then 3/2 v to the 1/2 dv is du. So then since u to the 1/2, or sorry, v to the 1/2 was u to the 1/3, then you have 3/2 v to the 1/2 times v to the 1/2 dv, and then v to the 1/2 times v to the 1/2 is v, so that 3/2 v dv. So that's where that all comes from. So now what I would do then is I would bring the 3/2 out, so the 3's divide out. So I have 1/2 integral of, I'll write v e to the v dv, and then I would use integration by parts. So only then would I get to the part by integration by parts. So it is an integration by parts problem, but it requires a double substitution before that. So then what I would do is, let's just use the tabular method here. So the tabular method, you have the plus minus plus, and then u dv. So v 1, 0, e to the v, e to the v, e to the v. So this integral is 1/2. Oh boy, yeah. So 1/2 uh, v e to the v minus e to the v. And so, well, then what you need to do is you would need to substitute back what the v's are. So if you end up back substituting, oh boy, I don't know if you want to go through all that, but just for the point of what this should be, if you back substitute, I guess I'll just write down the final answer at this rate. So this is, plus c. If I forgot plus c after all of this, that would have been really bad, right? So then this would be 1/2 times e to the x squared times x squared minus e to the x squared plus c. So hopefully you enjoyed that. But then, as you can see here, then the last problem, this one, this integral right here of just the e to the x squared dx with one of the non-elementary integrals. So that one, just as a reminder, joins a long list of other integrals that are ones that are non-elementary integrals. So that would be besides integral of like that would be all of these non-integral functions. So e to the uh, x squared, or there are there's a lot of them. Like uh, I'm not even gonna list them. I feel like you have that handout and that you can go back and look at them if you ever would like to again. So I hope that you enjoyed this also.